Hello, my dear students. I'm going to start a new chapter, that is Unit 6 in your Part 1 textbook, General Principles and Process of Isolation of Elements. So, in this chapter, you are going to get totally 4 marks. So, out of these 4 marks, 1 marks is from Part A question and 3 marks is from part C. So under part A, question number 6 you are going to get from unit 6, and under part C, question number 19, that is very first question number 19 you are going to get from this chapter. You are going to get totally 3 marks in the question number 19. So 4 marks question will come from general principles and isolation of the elements. So introduction of this part is the elements occur in the nature in the form of free as well as in the combined state. So usually you all know elements usually occur in the form of either free state or as combined state. So for example, carbon, sulfur, gold and noble gases, these are all occur in the free state, whereas other, for example, aluminium, iron, these are all occur in the combined state. So especially you are going to get all these elements from the earth crust. So minerals, the meaning of mineral, some of the important terminology you should know here. The naturally occurring chemical substances in the earth crust obtained by mining are called as minerals. So through mining we can get some of the important minerals, so which contain an element as well as some of the unwanted particles. So these are the naturally occurring chemical substances which are available in the earth crust. So especially we are going to obtain it by an mining. So next is ore. The meaning of term ore is it is a mineral from which metals can be extracted conveniently and economically, or called as ores. So usually all ores are minerals, whereas all the minerals are not an ore. So these minerals from which the metals can be extracted, that is which we wanted to be extract. For example, iron we are going to extract, for example aluminium we are going to extract, so that are also called as ores. So we are going to extract it conveniently as well as economically. So usually all ores are minerals, whereas all the minerals are not an ore. So this is the important terminology you are going to learn. So some of the other important terminologies, that is gang. Gang means it is an unwanted impurities, you can call it as an impurity. Flux means it is an substance that is added to the molten metals to bond with the impurities. And slag means it is also an waste material which can be removed it. And the term metallurgy, that is you can give an name for this chapter as a metallurgy also. So metallurgy means it is an entire scientific and technological process used for the isolation of the metal from its ore. In order to extract the metals from its ore, we are going to use this technique called as metallurgy. This is about the introduction of this chapter. So under the occurrence of the metal, so you are going to extract an aluminium, iron, copper and then zinc. This is zinc. So under this aluminium, bauxite, kaolinite and cryolite are the ores of the aluminium, whereas it has the such a composition. And from aluminium can be extracted from this bauxite ore. Iron, it has an ore of hematite, magnetite, siderite and then iron pyrites. These are all the composition of that, and from an hematite we can easily extract an iron. Copper is copper pyrite, malachite, cuprite and copper glans. So usually we are going to extract copper from cuprite and then copper glans. So these are all the composition. and zinc blende, zincite is an ores of the zinc. So usually from the zinc blend and then zinc oxide we can extract the zinc. So these are all the occurrence of the different metals: aluminium, iron, and then iron, copper, and then zinc. So next is the occurrence of the metals. So under this again, among the metals, aluminium is the most abundant metal. So aluminium is the most abundant metal. Iron, calcium, sodium, and potassium are the second, third, fourth, and the fifth most abundant metals. So more electropositive metals. So usually an alkali and alkaline earth metals are called as electropositive metals. Generally they are occur in the combined state. How they are going to occur? As an halide and then as a nitrites they are going to occur. Magnesium nitrite and sodium chloride. So these are the electropositive metals occur as an halide and a nitrite. So next is the least reactive metals occur in the free state or in the native state. For example, gold, silver, platinum are occur in the free state. So what are the principles involved in the extraction of the metals? This can be explained in this slide. Concentration of the ore, isolation of the metal from its concentrated ore, and purification of the metal. So there are three important methods in order to extract the metal, that is concentration of the ore, isolation of the metal from its concentrated ore. So first now ಏನು ಮಾಡ್ತೀವಿ, we are going to concentrate the ore. Concentrate means in order to we are going to remove an unwanted materials here, therefore it is called as concentration of the ore. So after that we are going to extract an metal from the concentrated ore. Next, last method is that of purification. We are going to purify the so extracted metal from the second step. This is the three different principles and the methods involved in the extraction of the metals. So first method is concentration of ore, the process of removal of the unwanted materials. So as I have told, unwanted materials, as we are going to extract the metals, ores from the earth crust, it may contain sand, clay, etc. So these are obviously an unwanted material. From the ore is known as ore concentration, ore dressing, or else you can call it as ore benefaction. So based on the difference in the physical as well as chemical properties of the ore and gangue particles, different methods are adopted for the concentration of the ore. So based on their physical and chemical properties of ore and then gangue particles. So gangue particles antandre, so as I have told, it is an unwanted impurities which is present in the ore. So as we are extracting it from that of earth crust. So based on their physical and chemical properties, we can have a different methods of concentration of ore, and those are hydraulic washing, magnetic separation, froth flotation method, and then leaching. So under this hydraulic washing we are going to use an water. Under magnetic separation, as the name says, we are using an magnet here. Froth flotation method, so here we are going to form an foam or lather, so it can be called as froth, so therefore it is called as froth flotation method. And the last one is leaching, so this is one chemical method. So the method we can explain here. Hydraulic washing, this method is based on the difference in the gravities of the ore as well as the gangue particles. So this is called as gravity separation method. So gravity, depending upon the gravity, we can make a separation of ore as well as the gangue particle. So procedure involved here is the powdered ore is washed with an upward stream of running water. The lighter gangue particles are washed away and the heavier ore particles are left behind. So here we are going to use a water. So upward stream of running water. So forcefully we are going to use the water. With the more of force we are going to use the water, that is running water. So usually lighter gangue particles will be very much lighter, therefore they are going to wash away, whereas the heavier ores will be left behind. And here examples in which we can use this hydraulic washing is gold, oxide ores like hematite, bauxite, etc. Aluminium can be concentrated, iron can be concentrated, and then gold can be concentrated. Next is magnetic separation, the second method. This method is based on the differences in magnetic properties of the ore and the gangue particles. So as I have told, we are using an magnetic property here because it is an magnetic separation. So here the procedure involves the powdered ore is carried on a conveyor belt. This is an conveyor belt which passes over two rollers. So here you can observe there is a presence of two rollers, one of which is a magnetic. So here you can observe this is a magnetic roller. The magnetic particles get attracted to the magnetic roller and fall near to it, while non-magnetic particles fall away from the roller. So here you can observe we have put an two containers, so which is nearer to the magnetic roller and which is away from the magnetic roller. So as the ore particles has been passed through this conveyor particle, the conveyor belt starts moving because it contains two rollers. It going to start move like this. So ಈ ಥರ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. So if there is a presence of any magnetic particles, that is for example iron, so here you can see iron ore. If there is a presence of iron ore, it will be collected in this which is present near the magnetic roller, and secondly the non-magnetic particles will be collected in the second one, that is non-magnetic particles. So illi collect ಆಗುತ್ತೆ. This is the magnetic separation. So for example iron ore can be separated, stannous oxide, cassiterite can be separated like this. Third method is froth flotation method. So principle involved here is this method is based on the differences in the wetting properties. So wettability, we can call it as an wettability of the ore and the gangue particles by oil and then water. So usually the ore particles become wet by oils. Please remember here the ore particles become wet by oils, whereas gangue particles become wet by an water. So wettability between an oil and water molecule. So oil can wet the ore particle, whereas water can wet the gangue particles. So for example sulfide ore can be concentrated by this froth flotation method. So the powdered ore is suspended in a water. Collectors like pine oil. So here oil is used and froth stabilizers like cresols or aniline are added. So froth stabilizers. So collectors in order to make a wet the ore particle, whereas froth stabilizers in order to give a stability for the so formed froth. So collectors enhances the non-wettability of the ore particle with that of water. So the so formed used pine oil for example, so it will avoid the wettability of ore particle with that of water, whereas froth stabilizer will stabilizes the so formed froth form. Froth is nothing but a foam like structure, lather like formation. The ore particles become wet by oils while the gangue particles by that of water. The mixture is agitated with the help of a rotating paddle. So I am going to show you the apparatus, and air is drawn into the suspension. As a result, froth is formed which carries the ore particles along with it to the surface. So the so formed froth is going to carry the ore particles through its surface. So ore ಎಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ, ಸರ್ಫೇಸ್ ಲೇಯರಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ. ದ ಫ್ರೋತ್ ಈಸ್ ಲೈಟ್ ಆ್ಯಂಡ್ ಈಸ್ ಸ್ಕಿಮ್ಡ್ ಆಫ್. ಸೊ ಫ್ರೋತ್ ಯೂಶ್ವಲ್ ಆಗಿ ನೊರೆ ಹೇಗಿರುತ್ತೆ, ತುಂಬಾ ಲೈಟ್ ಇರುತ್ತೆ. ಸೊ ದೇ ಕ್ಯಾನ್ ಬಿ ಸ್ಕಿಮ್ಡ್ ಆಫ್. ಸ್ಕಿಮ್ಡ್ ಆಫ್ ಮೀನ್ಸ್ ವಿಚ್ ಕ್ಯಾನ್ ಬಿ ರಿಮೂವ್ ಈಸಿಲಿ. It is then dried to recover the ore particles. So here you can observe the apparatus. This is a rotating paddle in order to rotate. So here we are going to add an ore as well as oil. So paddle draws in air and stirs the pulp. So mineral froth is nothing but an ore particle which is present in it. froth. Sometimes it is possible to separate two sulfide ores by adjusting proportion of oil to water or by the using the depressant. So depressant means it is a chemical which inhibits the or prevents the absorption of a collector by a mineral particle and thereby prevents its flotation. So for example, in case of an ore containing zinc sulfide and then lead sulfide. So ಎರಡರಲ್ಲೂ sulfide ಇದೆ. The depressant used is sodium cyanide. It selectively prevents zinc sulfide from coming to the froth but allows lead sulfide to come with that of froth. So ಎರಡು ಸಿಮಿಲರ್ ಓರ್ಸ್ ಇರುವಾಗ ನಾವು we can use this depressant. So depressant means it is an chemical which inhibits the absorption of a collector by a mineral particle and thereby prevents the flotation. So last method under a concentration of ore is chemical method, or you can call it as leaching. So this method is based on the differences in solubility of the ore and the gangue particles in suitable solvent. So here we are going to use a suitable solvent, organic solvent na use ಮಾಡ್ತಾ ಇದೀವಿ. This is used when the ore is soluble in some suitable solvent. For example, alumina from the bauxite, we can be extract aluminium from bauxite ore. The principal ore of aluminium bauxite, which contains silicon dioxide, iron ore, iron oxide and titanium oxide. So usually bauxite alli silicon dioxide is an impurity, iron oxide is an impurity, titanium oxide is an impurity. So first here powdered ore is digested with a concentrated sodium hydroxide solution at a 473 to 523 Kelvin temperature and 35 to 36 bar pressure. So at a very high temperature the reaction is going to take place here. Aluminium oxide will dissolve in that of sodium hydroxide and leached out as an sodium aluminate. Here you can observe the reaction, and silicon dioxide as an sodium silicate. The impurities are left behind and are separated by the filtration. So aluminium oxide reacts with the sodium hydroxide. So here we are using an water molecule in order to form an sodium aluminate. So when in the second step, carbon dioxide gas is passed through the above solution, the aluminate, that is sodium aluminate, in the solution is neutralized and a precipitate of hydrated alumina is formed. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಸೋಡಿಯಂ ಅಲ್ಯೂಮಿನೇಟ್ನ ನಾವು ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪಾಸ್ ಇಟ್ ಥ್ರೂ ದ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್ ಇನ್ ಆರ್ಡರ್ ಟು ಫಾರ್ಮ್ ಆನ್ hydrated alumina, whereas sodium bicarbonate as a byproduct. The sodium silicate remains in the solution. So illi as an impurity irutte. Hydrated aluminum oxide is filtered, dried and heated. So illu kuda at a very high temperature the reaction takes place to give back pure alumina. So aluminium hydrated aluminium ಮತ್ತೆ ನಾವು ಹೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ at a very high temperature. ಸೊ ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್ ಅಂದರೆ ಅಲ್ಯೂಮಿನಾ ಸಿಗ್ತಾ ಇದೆ and then dehydration ಆಗ್ತಾ ಇದೆ. In the metallurgy of silver and gold, the respective metal is leached with a dilute solution of sodium cyanide and or potassium cyanide in the presence of air, from which the metal is obtained later by the replacement. So idu reaction nanu at the last of this chapter I am going to show you. So now we have concentrated the ore, that is we have removed the unwanted material gangue particles na remove ಮಾಡಿದ್ದೀವಿ. Next is the extraction of the crude metal. So ಈಗ ನಮಗೆ ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್, ಕಾಪರ್ ಸಲ್ಫೈಡ್ ಈ ಥರನೇ ಇದೆ, ಜಿಂಕ್ ಆಕ್ಸೈಡ್ ಈ ಥರನೇ ಇದೆ ಇನ್ನು. ಸೊ ದಟ್ ಈಸ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ಓರ್ ಅಷ್ಟೇ ಆಗಿರೋದು. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಆನ್ isolation of the metal now. So that is nothing but an extraction of the crude metal. So this can be takes place by a two different method: conversion of concentrated ore into oxide and reduction of the oxide into the metal. So first ನಾವು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಓರ್ನ ಆಕ್ಸೈಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ, ಫಾಲೋಡ್ ಬೈ ಆ ಆಕ್ಸೈಡ್ನ ನಾವು ಮೆಟಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಫಸ್ಟ್ is the conversion of the ore into the oxide. So here in this conversion of ore into oxide, ores are generally converted into their oxide either by roasting or by calcination. So there are two different methods in order to convert the concentrated ore into their oxide. ಸೊ ಕೆಲವೊಂದು ಜಿಂಕ್ ಸಲ್ಫೈಡ್, ಕಾಪರ್ ಸಲ್ಫೈಡ್ ಈ ಥರ ಇರುತ್ತಲ್ಲ ಅದನ್ನ ನಾವು ಪ್ಯೂರ್ ಆಕ್ಸೈಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ದೇರ್ ಫೋರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಟೂ ಮೆಥಡ್. ಫಸ್ಟ್ ಒನ್ ಈಸ್ ರೋಸ್ಟಿಂಗ್. ಸೊ the process of heating the ore in a regular supply of the air in a furnace at a temperature below the melting point of the metal, that is very much important. It is called as roasting. So we are going to heat the ore, concentrated ore, in the presence of an air, so at a temperature below the melting point of the metal. So this is called as roasting. The ore gets converted into its metal oxide or other desired compound. Here you can observe I have given an 3 example. Zinc sulfide is converted into zinc oxide, lead sulfide is converted into lead oxide, copper sulfide is converted into copper oxide. So this is the roasting. Next is the second method is calcination. The process of heating the ore either in the limited supply of air or in the absence of air at a temperature same below the melting point of the metal is called as calcination. So during this calcination, the volatile matter escapes and the ore gets converted into metal oxide. For example, already there is an oxide, whereas it is in this case it is an hydrated oxide, right? Hydrated iron oxide is present. Therefore, we are going to remove this water molecule in order to form an pure oxide. Then zinc carbonate can be converted with the limited supply of an air in order to form an zinc oxide. Calcium carbonate, magnesium carbonate is converted into calcium oxide and then magnesium oxide. Here you can observe these are the volatile compound, carbon dioxide, water molecule. So form they are going to escapes out easily. So this is the conversion. Illi conversion ಆಯಿತು. First conversion of concentrated ore into oxide. So next method is reduction of oxide into metal. Reduction of oxide to the metal. Here we are going to convert the oxides into its pure form of metal. So here you can observe a metal oxide can be reduced to metal by heating the metal oxide with a suitable reducing agent such as carbon, carbon monoxide or any other metal. So oxides na ನಾವು ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಮೆಟಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ with the help of reducing agent. So the reducing agent combines with the oxygen of the metal oxide. So for example, this is a metal oxide. When it is treated with an reducing agent, so here the reducing agent reduces the metal oxide into metal, whereas it itself convert into oxide. Ee tara convert aagta ide, right? This is the reducing agent combined with that of oxygen of the metal oxide. Here you can observe metal oxide, when it is combined with that of reducing agent, it is converted into metal and then carbon monoxide is formed. So reducing agent itself oxidized, reducing agent oxidize ಆಗ್ತಾ ಇದೆ, whereas ಅದೇನು metal oxide ಇತ್ತು ಅದು reduce ಆಗ್ತಾ ಇದೆ ಇಷ್ಟೇ. The oxide is reduced to the metal and the reducing agent is oxidized. The reducing agent forms its oxide when the metal oxide is reduced. So there are some thermodynamic principles, thermodynamical aspects are present in this form, in this metallurgy. That is selection of the suitable reducing agent, it is very much important. Optimum conditions for the reduction is needed and feasibility of a reduction is needed. So feasibility of a reduction anta andre, so it is the reaction occurs spontaneously, which means there is no extra energy need to be put into the reaction to occur. So that is known as feasibility of the reaction. This can be predicted on the basis of free energy change, that is Gibbs free energy. You have heard about this in the thermodynamic aspects of that process. So the change in Gibbs free energy for any process at any specified temperature is described by the equation delta G delta H minus T delta S. Here delta G is change in Gibbs free energy, which can be expressed in kilojoule per mole. Delta H is change in enthalpy, and again enthalpy is an energy, it is also expressed in kilojoule per mole. And T, that is temperature, whereas delta S is change in entropy, that is degree of randomness. So degree of randomness, you can call it as it is an measure of disorderness. So measure of a system thermal energy per unit temperature, that will give us an entropy. So that is unavailable for doing useful work. The criterion for the feasibility of the reaction at any temperature is delta G of the reaction should be negative. So feasibility of the reaction ಆಗಬೇಕು ಅಂತ ಅಂದರೆ ಏನಿರಬೇಕು, ಡೆಲ್ಟಾ ಜಿ ಶುಡ್ ಬಿ ನೆಗೆಟಿವ್, ವೆರಾಸ್ ಯೂಶುವಲಿ ಡೆಲ್ಟಾ ಜಿ ನೆಗೆಟಿವ್ in this you are going to get in only one reaction. If delta G is positive, then on increasing the temperature, the value of T delta S increases and then delta G value become negative and the reaction proceeds at high temperature. So delta G positive idre, at that time we can increase the temperature. So if the temperature increases, obviously the T delta S increases and therefore the delta G will become positive. The delta G will become negative. A reaction with positive delta G value can be made to occur by coupling it with another reaction having more negative delta G value, so that the net delta G of the reaction is negative. So the reaction should be delta G should be negative. This will say that delta G of the reaction will be occur in a feasibility of the reaction. So that is gives free energy ಏನಿದೆ, which is an thermodynamic potential, which can be used to calculate the maximum reversible work that may be performed by a thermodynamic system at a constant temperature and pressure. So that will be a easily occurred, ease of the reaction will be shown. So delta G of the reaction should be negative here. So the role of the reducing agent is to provide delta G naught negative. So reducing agent in the role it should provide a delta G naught, that is standard state free energy, negative and large enough to make the sum of the delta G naught of the two reactions, that is oxidation of the reducing agent and reduction of the metal oxide, it will be negative. The standard free energy is calculated when 1 mole of oxygen is used for the formation of metal oxide. As the temperature increases, delta G naught value also increases and hence oxides are unstable at high temperature. So this is about the thermodynamical aspects which are involved in this, and in the next class I am going to explain you about this Ellingham diagram, which is very much important. So please go through this video, and if there is any doubt you can clarify with the same, and in my next class I am going to explain about the Ellingham diagram. Thank you.